In this session, we are going to learn about the gradient and tangent to the level curve. Well, let's take a look at what is written here. It says, at every point x0, y0 in the domain of a differentiable function fxy, the gradient of f is normal to the level curve through x0, y0. Well, let's take a look at the graph below. When it says the gradient of f, okay, you can see from here, this gradient of f, which is represented by this arrow, the blue arrow here, if it is normal to the level curve, which means it will be perpendicular to the tangent line at the point x0, y0. Okay, let's take a look at the example here. It says, find an equation for the tangent to the ellipse x squared over 4 plus y squared equals to 2 at the point -2, 1. So before we can find out what is the equation for the tangent, okay, just now we have learned how to we have learned about this gradient of f before, and now we want to find the equation of tangent. So first of all, we have to find out what is the f. Okay, so from this equation, make sure the right hand side of the equation does not contain any terms that have x or y. Make sure it is just purely number. After that, we'll take the left hand side as the fxy and the right hand side as the c. So after you have obtained what is the f, our next step is to find the gradient of f, where gradient of f is equals to del f del x as the first component and del f del y as the second component. Then we're going to find what is del f del x. From the expression, del f del x is equals to 2x over 4 and del f del y is 2y. And from there, we are going to find what is the gradient of f at the point -2, 1. Well, we substitute x with -2 and y with 1, and we get the first component equals to -4 over 4, that gives us -1. And the second component will be 2 multiplied with 1, which gives us 2. So our gradient of f at the point -2, 1 is equals to -1, 2. So we're going to use this gradient of f to find the equation of line, the tangent line. How? Let's recall, if we have a line, okay, and we have a normal, a vector that is perpendicular to the line. Let's say this vector, it is AB, okay, and let's say this line contain a point x0, y0. Then the equation of line, it will be ax plus by equals to ax0 plus by0. Okay, refer back to the question just now. Our AB is equals the normal vector. The gradient f is equals to -1, 2. Okay, and the point is x0, y0. It is equals to -2, 1. So our equation of the tangent line will be -x plus 2y equals to -1 multiplied with -2 plus 2 multiplied with 1. which gives us 4 at the right hand side. And well, of course you do not like to have negative in the first term, then you can multiply left and right with -1. That will give you x minus 2y equals to -4. And that's the equation of the tangent line. Let's take a look at the graph. Okay, you can see from this ellipse, okay, we are talking about the point here, -2, 1. At this particular point, we have a gradient of f that is -I plus 2j, or -1, 2 if it is in angle brackets. And the equation, just now we have found out that the equation of the tangent is x minus 2y equals to -4, and this is the equation. And this red line is the tangent line for the ellipse at the point -2, 1.